This section is 11-1. Students, you will be held responsible. You will be held responsible for this material. So please take notes. I will be checking tomorrow for a grade. If you are talking during this time and you do not get the notes from this recording, you will get a 0. All right, so we are talking about square roots. In this chapter, I am requiring that you learn your perfect squares or your square roots up to 25 squared. You can really skip 21, 22, 23, and 24, but you should know up through 20 squared. You should know that the square root of 400 is 20, the square root of 625 is 25, and you should know the square root of 289 is 17, the square root of 256 is 16, the square root of 225 is 15, 196 is 14, so 14 times 14 is 196, 169 is 13, and so this shouldn't be that tough because you already know 1 through 12 squared. Now you're just learning the rest. I think 18 is 324, 18 squared is 324, 19 is 361, and then 20 is 400. All right, so we're looking at square roots. Basically, it's an operation that gives a number when multiplied by itself, it gives you a different number. So 4 times 4 is 16. So the square root of 16 is 4. The thing about square roots, the big rule here, where fractions you can't divide by a 0. With radicals, you can't take the square root of a negative. There's no number times itself that will give you a negative. So whatever a is, it has to be a number that's greater than 0. So as I mentioned, 0 squared, and 0 is a perfect square, is 0. 1 squared is 1. So the square root of 0 is 0. 1 squared is 1. So the square root of 1 is 1. 2 squared is 4. So the square root of 4, that's the result, is 2. 3 squared is 9, and the square root of 9 is 3. And so on. If I square it and then I root it, is the result the same? Well, we can see with 5, 3, 5, and 9, it is. But what happens if we take a negative 3? When we square it, we get 9. But if I take the square root of 9, I don't necessarily get negative 3. So with that in mind, it doesn't work with negative numbers. Every positive number has 2 roots, a positive square root and a negative square root. We call the positives the principal square root. So the square root of 16 is 4. That's the principal square root. When I'm showing negative square roots, I put the negative on the outside. It's almost as if you have a negative 1 times the square root of 16. That's how we get negative square roots. But it's not the inverse or the opposite of a square because it only gives the 2 positive roots. So if I have x squared equals 100, then we know that x has to equal 10 or negative 10. But if I'm taking the square root of 100, negative 10 is not an option. So there's only one solution there. All right, so pause the recording, and what I want you to do now is you're going to simplify each root below and identify as many positive, and identify it as a positive root or a negative root. So pause the recording. I'll show you. For example, number 1, it's a positive root and it's 7. Number 2, it's a negative root and it's negative 5. Pause the recording and finish 3 through 8 for 1 minute. All right, now check your work. Number 3, you should have gotten a positive root, and it should be 12. Number 4 is 4, and it's a positive root. Number 5 is 6, and it's a negative 6, and it's a negative root. Number 6 is positive 6, and it's a positive root. Number 7 is negative 8, and it's a positive root. And number 8, I'm sure you all were discussing, this is not a real root. This is what we call as not a real root. It's part of the imaginary number system. So our real numbers, you can't take a negative square root in the real number system. In the imaginaries, you can do this. So we're going to say this is not a real root. I want to introduce some new words that we have here while we bring up real roots. Negative numbers do not have real roots. So the vocabulary for today's lesson is radical, radicand, and real numbers, real roots, irrational numbers. Now, the first one, a radical, that's what we've been learning about. It's just the fancy word for the square root sign. The radicand is the number inside the 16. I'm going to pause this. All right, so getting back to, sorry about that phone ring. Okay, now, so here we are. We're talking about our real numbers, our real roots, and our irrational numbers. The real numbers are any number in the real number system. That's basically any number that is not a negative square root. A real root would be the square root of 9, so that's 3. 3 would be a real root. And an irrational is any number that's not a perfect square, like the square root of 6, square root of 8, square root of 7. And those numbers, if you looked at them on a calculator, they go on and on forever with no particular pattern. They're just like pi. So they're non-terminating, non-terminating, and there is no particular pattern to them. They're non-repeating either. All right, so now let's take it back to the lesson. So here we go. Okay, so I'm actually going to teach you how to do this without the calculator. When we're looking for the square roots, the first thing you need to do is go to the square root, the two integers, the perfect squares that 21 is between. So I'm going to say that 21 falls between the square root of the closest square roots. It falls between the square root of 16 at the top and the square root of 25 on the bottom end. So we know the root of 16 is 4 and the root of 25 is 5. Somewhere in the middle is the square root of 21. So I could say we have the square root of 17, the square root of 18, the square root of 19, the square root of 20, got the square root of 21, the square root of 22, square root of 23, square root of 24, and the square root of 25. So we said the square root of 16 is equal to 4, and the square root of 25 is equal to 5. Now, if you look at, I'm going to look for a halfway point. I'm going to look for exactly in the middle. If I move in 1, 2, 2, 3, 3, 4, 4, 25, 21, looks like that halfway point is right between here. That if I'm looking in terms of roots, would be about 4.5. So now I have a better way to estimate the square root of 21. It basically falls closer to the 5, and it's more than halfway. But it's pretty close to halfway. So I'm going to estimate that at about 4 6/10. 4 6/10. Now, if I use a calculator, you basically punch in the number and then hit the square root sign. The original number 21. You'll see it's pretty darn close. My estimation was 4.6, so I am 2/100ths off from where my estimate. Now, these are not exact, okay? We actually like to keep them in the radical sign because they're more exact than when we estimate. But in case you have to estimate, that's what you have to do. Again, take a look at it. I kind of look at where it falls. In between, it's about halfway. That's 4.5. And so now I'm saying it's a little bit more than 4.5. And I estimate it at 4 6/10. Now if you multiply it, it comes out pretty close. Okay, so I'm going to pause the recording. Let's do one more together. So we've got the square root of 7 falls between what perfect squares? I know you're saying. It falls between 4 and 9. So I've got 4, the square root of 5, square root of 6, the square root of 7, square root of 8, and the square root of 9. We know that 9 is 3 and 4 is 2. So it's somewhere. Is it closer to the 9 or is the square root of 7 closer to 4? Looks like it's exactly again going to be halfway in the middle. So it's a little bit more, but this time it's a little more than halfway between the integers 2 and 3. So it's about 2.58. So let's see how I did with that. And we check our estimate. And we get 2 65 hundredths. All right, so now you try it. Pause the recording. Take about 2 minutes, and what you do 2 and 3. 2 and 3. Pause it. Now check your work. Okay, so the square root of 32 falls between the square root of 25 and the square root of 36. Okay? The square root of 25 and the square root of 36. So I got 25, 26, 27, 28, 29. Let's start here because it'll be easier. Square root of 25, 26, 27, 28, 29, square root of 30, square root of 31, square root of 32, square root of 33, square root of 34, square root of 35, square root of 36. So one way that questions may be asked is, what two integers does the square root of 32 fall between? And in that answer, you would say between 5 and between 6. So the square root of 32, is it closer to the 36 or is it closer to 25? Looks like it's a little bit closer to 36. And so I would say my halfway point, 1, 2, 3, 4, 5, 6, would be about 1, 2, 3, 4, 5 in. This would probably 1, 2, 3, 4, 5. That's about halfway. That's 5 and 5/10. So it's a little bit more. I think I might guess this time. My estimation should be between 0.5 and 6, 5 and 5/10. So I'm going to guesstimate 5 and 7/10. If you check that on a calculator, pretty close. I'm 4/100ths off. So number 3, you should have gotten 7 and 48/100ths. Number 4 is very close to the square root of 100, which is 10. So I'm going to say 9 and 9/10. Number 5, it's between 100 and 81. It's closer to 81, so I'm going to say about 9.2, 9.3. Pretty close. 75 is between 81 and 64. It's closer to the 81. So I'm going to say about 8.6. Number 7 is about 10 and 3/10. And number 8 is about 4 and 36/100ths. All right, moving on. Now, when it says, let's forget about this. Let's look at round to the nearest hundredth when necessary. Well, these aren't between. We know that the square root of 121 is 11. And number 2 would be -20. Number 3, again, it falls between, let's just jump right to number 4. When you get something like this means positive or negative. So when I'm looking for the root of 81, I'm looking for the positive root and the negative root. So we would write plus or minus 9. So same way to say positive 9 and negative 9. Number 5 would be, we're going to estimate it. And so square root of 18 falls between 4 and 5. And so we're going to say it's plus or minus 4 and 24/100ths. Now, when I get something like this, what this means, this means 2 plus the square root of 99 and 2 minus the square root of 99. So if the square root of 99 is about 9 and 9/10, or 9 and 95/100ths, we're going to add it and we're going to subtract it. I generally branch it like this. Let's go back. I would take, when you see plus or minus, and I'm going to say 2 plus 9 and 95/100ths. Then I'm going to say 2 minus 9 and 95/100ths. And so we get 11 and 95/100ths, and we get 7 and 95/100ths, negative 7 and 95/100ths are our 2 answers. All right, next one. So I said to you, I want you to know your perfect squares through these numbers should come to you inside and out. I said that during back in chapter 6 when we were doing perfect square trinomials. But you'll notice that the square root of 1 is 1. What about 2 and 3? The square root of 2 is irrational. If you take the square root, it equals a number that goes on and on with no particular pattern. The square root of 3 is also irrational. Square root of 4 is rational because it gives me a number. A rational number is any number that can be written as a fraction. So 4 is really equal to 2, and 2 we can write as a fraction. It's any number that can be written as a ratio of 2 numbers. Square root of 5 is rational. Square root of 6 would be rational. Square root of 7 would be rational. And the square root of 8 would be rational. But the square root of 9 is not rational. That would equal 3. The square root of 9 is rational. Yet these others are irrational. So if you follow the pattern, we go all the way up. Pause the recording and see if you can finish it. Hopefully up to 81 you should be able to. All right. Now, recognizing rational roots. Any rational root is a perfect square. And again, these you should know all the way up through 20. 20 squared is 400, so you should know 19 squared. If we show the diagram, they look like this. Sorry about that. And the next would be 6 by 6, which make 36, 7 by 7, which would make 49, and 8 by 8. So square root. Now, take a minute and identify the following numbers as irrational or rational. Remember, the irrational numbers are the ones that are not perfect squares. So number 1 would be irrational. Take a minute, pause the recording, and just state whether each of these are rational or irrational. Now check your work. Number 2 is rational. Number 3, irrational. Number 4, it's rational. Number 5, negative roots are rational. Number 5 is irrational. Number 6, irrational, where number 7 is rational. Number 8 is rational. Number 9 is irrational, and number 10 is rational. So we're going to skip this slide, except for the last problem. What would we say about that? Number 10. Number 10 is not a real root. Okay? Because it's a square. Now, here they're just asking for you to determine what two consecutive integers the root lies between. So square root of 7 falls between the square root of 4 and the square root of 9. That means it lies between the integers of 2, which is the root of 4, and 3. Square root of 20 now falls between the perfect squares of 16 and 25. Square root of 16 is 4, and the square root of 25 is 5. So the square root of 20 is somewhere between 4 and 5. Now pause the recording and do the next two problems. Take about a minute. Now check your work. Falls between 81 and 100. It's 9 and 10. Next one is 6 and 7. Pause the recording if you need to rewrite some notes. So more numbers to practice with. Let's go through this and figure out if we... Now it says to estimate the irrational root to the nearest tenth without using, well, I never really taught you to use the calculator. So you're either, the directions will either ask you to estimate to the nearest tenth or estimate between what two integers it falls between. So this is a little bit more of the same. Now, find the side. If you're looking at a square and we look at the area as 49 square units, a side is the square root of that. So that would be side is equal to, it could be the negative or the positive. But remember this, distance can't be negative. So there's no way this can be a negative root. So its only answer is 7. A measurement can only be one distance. A, remember, it's a number. What two roots does 40 fall between? It falls between 36 and 49, so it's somewhere between 6 and 7. Is it closer to 49? Is it closer to 36? It's a little bit closer to 36, so I would say 6 and 3/10. Let's see how my guesstimate works. Ooh, perfect. So, that is lesson 1. You are responsible. Homework is 11-1. It's on the board. You're doing page 485, 1 through 51 odd. That's the end of the lesson.